Hi, my purpose in recording this video is really twofold. One, I want to review the material that we've covered thus far regarding private methods and parameter passing. And then secondly, I also want to talk about the final project a little bit, make sure that everybody understands completely what needs to be done. So I'll begin here in a moment, but before I do, I also want to apologize, if apologize is the word. But I also want to make you aware that I'm still suffering from some cold-like symptoms, and I may start coughing at any moment. So if I do, my apology, and I'll apologize up front one time and then try to control it. But should I lapse into some coughing and hacking fit, please understand, doing the best I can right now. Okay, so first thing I'm going to do is take a look at the final project specifications, and these have been given to you already. And I'm not going to, read line by line through the details. That's up to you, but I'm going to jump down here immediately to this structure chart, which shows the different subroutines or private methods rather that are involved in the making the whole process work. So there is a driver method shown at the very top, so everything sort of happens at the direction of this timer tick event. So this is an event method associated with a timer, and we have previously looked at the timer control class and how once we create a timer object, how we can adjust its enabled property and its interval property to make it activate or deactivate, and also control the speed at which it pulses or ticks. So this is going to be the main calling method. So you're going to see in this method, when it's all done, 1, 2, 3, 4, 5 method calls. So with every tick of this timer tick event, it will execute 5 method calls, and then the next tick it'll issue the same 5 method calls all over again. If we follow the path to the first method call, you'll see that I've chosen to call this method getTimeDate, and I suggested in class that you name your methods the same way, because if you need help, if you get stuck, if you have problems, it's going to make it that much easier for you to ask me questions, and I'll more or less know immediately what part of the program that your problem is in. So this project uses both void type and return type methods, and I have indicated whether methods are void type or return type in the structure chart, so make note of that. I've also indicated the parameters that are involved, and where I have used the letter R, I'm alluding to a reference parameter, and where I've used the identifier V, I'm alluding to a value parameter. So as I explain things here in a moment, as we look at program code, I'll go back and review the details of value and reference parameters, but at this point, even if you didn't understand the details 100%, if you've been in class and you've been following along, then you should understand that there at least are 2 types of parameters involved. When the timer tick event method calls the void type method getTimeDate, this guy is going to do really a couple of things. It's going to query the system clock and get the date time that we've seen as a string value, and looked at and worked with as we've used the substring method. So it's going to yank that big long string off the system clock, and then it is going to make calls to these return type methods, passing that string value, that same string value, to each one of these methods. So it yanks the time and date off the clock once, passes that string to each one of these methods. Each method gets exactly that same string, and each of these methods down here will have the specialized program code necessary to perform a very specific task. In this case, yanking the hour out of the string and returning it. These are return type methods. Returning that single substring value, yanking the minute out, and returning that single substring value. And when these methods return their individual substrings, those substrings are going to be assigned to, they're going to be called up through an assignment statement, and that return value is going to be assigned to these reference parameters. Give me a second, please. Okay, so I'm going to basically ignore this part of it for a moment. Let me go there. So once these reference parameters have been assigned a value, they are the same memory location as previously declared local variables in the timer tick event. So by the time this method makes its last method call to yank AM PM and control passes back to get time date, control will then pass to the timer tick event again, and all those local variables, the ones that are storing the hour, the minute, the little error right here, that should say second. Let's yank sec. Once all those reference parameters have been populated, since they are the same memory address as a local variable back here, then those local variables will have a value, at which point they can be passed to the subsequent methods in order to convert values from base 10 to base 2 and to display the output and so forth. Okay, so that's the final project, in kind of a 20,000 foot view. Minimize that. And I'm going to open up a prototype program. Okay, so I've written a little bit of this program, but not the whole thing. And if I start out by showing you how this program looks, then we'll look at the details of it here in a second. You'll notice that it is fairly early in the morning. Okay, and I have pointing to the clock down here at the bottom, and this display that Windows provides in the bottom right corner is getting its update from the same system clock that I'm calling through my program here. So these guys should be fairly well synced up, and as soon as this guy hits 60, this should flip over to 432. Okay, it just did then. Alright, so all I'm showing is the seconds part here. I've also got a button. This isn't exactly how you can do the optional, one of the optional parts of this program, but if you look at my code and understand my code, it will give you insight into how to do this part of the program yourself. But I've got a button that says Sunday, and if I click sun, it shows a picture of the sun and then toggles this to moon, and if I click this, it shows the moon and So I can toggle back and forth. Okay, and the program code is allowing me to assign a image to a picture box at runtime. So we've done this before, I know, by assigning background images to picture boxes at design time, but it can also be done at runtime as well. And again, I'll show you the details of that. Okay, so here's the program. Let's take a look at what's going on there. So if you recall, the main calling method here is going to be the timer tick event. I have a timer. I have the timer's enabled state set to true, so by default that's set to false, but I changed that at design time so that the timer, when the program starts, will immediately start running. The interval property is set to 100, which will allow this to execute the program code in the timer tick event once every 1/10 of a second. And if we look at that program code, I can access it by going down to this tray where the timer control is docked and double clicking on it. It'll take me into the code window to the timer tick event, and I have two string variables, local string variables declared, and I have initialized them to an empty string. So this is an important thing that has to be done if I'm working with reference parameters in this way. I have to assign them an initial value. They have to have an initial value before they can be used. So I create these two variables, then I make a call to getTimeDate, and I use both of these variables as arguments, and I'm passing by reference, which means that I'm not passing the stored value. I'm not passing an empty string, a copy of the empty string, but rather I'm passing the memory address of that variable sec, and I'm passing the memory address of that variable AMPM. So when I use reference parameters, I'm passing the address of the variable as opposed to a copy of the data. If I use a value parameter, which is the default parameter, then I'm working with a copy of the data. And I had mentioned that reference parameters can, with large structures, conserve memory, so they're useful from that standpoint. They're also useful in that they allow me to use a void type method in a way that is logically similar to a return type method, but whereas a return type method restricts the number of return values to 1, a void type method acts like a return type method but allows me to essentially return multiple values. And again, I'll say more of that as we go along here. So I make a call to getTimeDate, and so program control would logically pass to my method getTimeDate. Okay, and that's exactly what you'll be doing, except you're going to be, declaring more variables in the timer tick event and passing more reference arguments than I do. So in my method header, if you look at the parameter list, I have to precede any reference parameter with the keyword ref. So that keyword ref appears both in the argument list and the parameter list, the corresponding parameter list. So I have a variable, I have a parameter for each one of my arguments, and since I'm passing by reference in both cases, arguments and parameters, I'm using the keyword ref to precede the parameter. Inside of the timer tick event, I declare a local variable called DT and assign it the string that I return from the system clock. And then I call up the first of my third level variables, yank_sec, and I pass it that date string. Okay, so I'm calling a return type method through an assignment statement, and I'm passing to that return type method a value. So I'm passing by value. There's no keyword ref denoted in the argument, And if I go down and look at the method header, you'll notice that there's one parameter, and again, I declare the data type with the parameter, but I don't have the keyword ref showing up. I'm passing by value, or I'm passing a copy of that memory location. Oh, I'm sorry, a copy of that data. So I'm passing by value, and this method can, completely obliterate the value in PDT, and when control passes back to get time date, the local variable DT will still be holding the value that had from this statement right here. So anything that this called method might do to alter that parameter is not going to have any lasting effect in the method from which it was called. So we'll be declaring a local string type variable called sec. I'll be decomposing the string so that I yank out the seconds component of the string and assigning it to sec, and then I return sec. And so control would pass back to my calling routine, and it would finish the assignment, and whatever that substring is that's being returned would be assigned to psec, which is actually a reference parameter, which is the same memory address as sec back here in the timer tick event. So at that moment in time, sec has just gotten, that local variable sec has just gotten a substring that was created 2 method calls away. So if you're following along, I'm in the timer tick event. Control would then pass to this assignment where the very same kind of thing is going to occur. That same string here is being passed, a copy of it's being passed to yank AM PM. Yank AM PM receives it as a value parameter. It takes a substring of that value parameter and returns it, and that substring represents the last 2 characters, which are then assigned to P AM PM, which is a reference parameter, which in turn changes the value in the timer tick event's local variable AM PM. And once the return occurs from yank AM PM, that's the last statement to be executed here in my prototype get time date method. So control would pass back to the statement immediately beyond, since this is a void type method, we pass back to the statement immediately beyond where get time date was called, and that would be to this statement right here. And this statement would take the first character of what was previously a substring, now the value of sec, take that first character, assign it to my first label, take the second character of that same substring and assign it to the second label, so it's assigning 1 character per label, and then it assigns the entire AM or PM part of it. Those last 2 characters of the string are assigned to label 3. And when I run the program, again, that's the first character that was yanked out of the substring, that's the second character that was yanked out of the substring, and this is the entire substring. Okay. And I think I am now to the point where I can look at the button click event. Let's take a look at it and see how this is working. So if I double click on the button here, which happens to be button 1, and look at the program code, again, this is much like the house program and the light switch, that kind of logic. I look at the button face. If it says moon, then I want to load the moon picture. And how do I load the moon picture? I use the .NET object image, which has a from file method. So that's object dot method notation, and when I call up that method, I have to pass an argument, a string argument, and that string argument is the name of the file that I want to load into the picture, and I want to load that image into the background image of picture box 1. Okay, so I'll show you something else here in a moment, but notice that object, method, and that method has an argument, and I'm passing a string to that .NET objects from file method, and it will load a picture that corresponds with that string into, assign it to, the background image of picture box 1. So if the button says moon, it loads the moon picture and then changes the button to sun, else it does just the opposite. Okay, now what I wanted to show you is, minimize this, in my project, which starts with this outer folder, Clock Proto, if I, actually, let me go up a couple. Okay, here's Clock Proto, right? If I double click here and then double click again, I'm in the interior project folder and I see the bin folder. If I double click on bin and then double click on debug, this is the default folder for any external files that the application needs, and I'm putting the picture files right inside of that folder. Now these are files that I downloaded from the internet, and just to be perfectly ethical, I want to let you know up front, these are not files that I created. I did not indicate anywhere where I got these. I'm not using this for commercial purposes, it's for educational purposes, so since I get no financial advantage in doing this, I feel perfectly content. If you were doing this yourself with commercial, with software that you were developing commercially, then you would definitely want to go to whatever the commercial website is, go through the process of purchasing the file, which is not terribly expensive to buy stock photos, but then if there's commercial gain, you would want to cover yourself legally and do what's ethically responsible and pay for the resources that you're using. Okay, so that is pretty much everything I have in my prototype program, and I have an older version of this that I wanted to run for you, okay, and just so you can see what it looks like. And this is not exactly like what you're going to do, but it's similar. If I run this exe file, this is the way I envision your program looking, somewhat like this at least. Okay, so there would be the time shown in base 10 in 12-hour mode, and I would display the minutes, the hours and the minutes in base 2. You don't have to do that for the seconds, but if you want to, that's fine. It's not that hard, it's really not. But we display in both base 2 and base 10 concurrently. The date would be displayed down here, and then there would be a button, which mine is not working. Okay, so the prototype program, I just didn't write the code for it, but yours would toggle the date here between 12-hour and 24-hour mode. So at this point in time, everything would be the same. 4:47 a.m. is the same as in either mode, but 1 o'clock in the afternoon is going to be 1300 hours, 2 o'clock 1400, and so forth. So you would write the program code to make that adjustment, and then if it's 2 o'clock in the afternoon, this would be reading 10, and then these would be all zeros here. Okay, so that is pretty much the way this should look. And then notice this kind of rotational marquee up here at the top. You can study the way that's working. Excuse me. Okay, I think that's everything, and I'm about ready to go drink some tea.